Alright, welcome in this lesson. So now we will explore the pre-order traversal of a binary tree, right? So given a binary tree as input, our goal is to output a list of node values in the pre-order sequence, right? Which means visiting the root node first, then the left subtree, and finally the right subtree. So for example, consider this given tree. So if you see over here, node 1 has no left child, but it has a right child node 2, right? Which itself has a left child node 3. So the pre-order traversal of this tree will be 1, 2, 3. Because we visit the root node first, which is 1, then we go to the left subtree, which is essentially null. So we just return back to the root and then go to the right subtree, which has node 2. So we just print that. Then we visit the left subtree of 2, which has node 3. And so we print 3 now. And since 3 doesn't have any children, we simply come back to 2. And now 2 also doesn't have any right child. So we go back to 1 and finally return the final output, right? So that's the entire problem statement. Now maybe you can just pause this video over here and try to think of a solution on your own first. And then maybe once you are done, you can just come back and check the solution here. Okay, so now let's break down the algorithm for pre-order traversal step by step, right? So first of all, what we will do is we will create an empty result array to basically hold the traversal output, right? Which we will be returning at the end of our function, right? Next, we will define a recursive helper function, and maybe we can call it as traverse, right? And in this traverse function, for each of the node, first of all, we will check if the node is null or not, right? And if the current node is null, we will simply return the current result. Otherwise, we will first append the current node's data to the result array. Then we will recursively traverse the left subtree, and finally we will recursively traverse the right subtree. And after defining this helper function, we will call it on the root node of the tree first, which will then recursively keep traversing all the left and the right subtrees and keep appending to the result array, which we will finally return as the output of our function, right? So now maybe let's walk through the traversal process visually on our example tree. So starting at root node 1, we add it to our result directly. Next, we move to the right child, which is node 2, and add it as well, right? From node 2, we traverse its left child, node 3, and add it to the result. Now node 3 has no children, so we backtrack to node 2. Node 2 has no right child, so the traversal ends over here, and our final pre-order traversal is 1, 2, 3, right? Now maybe let's walk through the Python code implementation of this solution, right? So first of all, we will define the node class to represent each node in the binary tree, containing a data value and the pointers to the left and the right children, right? Next, we define the main pre-order function. And inside this pre-order function, we first initialize an empty result list, res, right? We then define the recursive helper function called traverse, right? And this function checks if the current node is none, right? And if so, it just returns the current result. Otherwise, it appends the node's data to res and recursively calls itself on the left child and then on the right child, right? And finally, we call the traverse starting from the root node and finally return the populated result list, right? So that's the entire solution. Now finally, let's analyze the complexity of this traversal. So the time complexity over here will be order of n, where n is the number of nodes of the tree because every node is being visited exactly once, right? And the space complexity will be order of h over here, where h is the height of the tree, and that is due to the recursion stack size, which could grow up to the height of the tree as we are traversing from the top to the absolute bottom of the tree. And in the worst case, if all the nodes of the given binary tree are skewed all at one side, then the space complexity will become order of n, right? So that's the entire solution. I hope you understood it well. And now I will see you in the next problem. Thank you.